Hello everybody. So before starting the presentation, I would like to thank the organization committee for giving me this opportunity to present my work and be one of the participants in this conference, which addresses very interesting scientific topics and very delicate problems of our society and our environment. So, as an introduction, among various semiconductor photocatalysts, titanium dioxide has been proved to be the most suitable photocatalyst for far-reaching environmental applications such as air purification, water purification, deodorization, etc. And that it's because of its biological and chemical inertness, strong oxidizing power, non-toxicity, and long-term stability against photo and chemical corrosion. But its wide band gap 3.2 electrovolts limits its usage in visible light and makes it absorbs just 3 to 5% of sunlight rays. Numerous studies have been carried out to develop the visible light activity of titanium dioxide through surface modification using various noble metals such as silver, gold, and palladium to reduce the rate of electron-hole pairs recombination, and also this can facilitate the transfer of electrons from the semiconductor to metal and leaves the holes for the degradation of organic compounds. Recently, some researchers have demonstrated that the new microwave-assisted method have more advantages than other methods because it allows a simple preparation procedure with fast heating, a good crystallization, and a uniform metal dispersion. So it's clean, faster, and with a low cost comparing to the other synthesis techniques. Powder XRD patterns were taken for the samples using the X-ray diffractometer, and the wavelength absorption was measured from the UV light region to the visible light region using the UV spectrophotometer. Results are depicted in the following figures. Figure 1 shows the difference between XRD patterns of titania and copper modified titania. The XRD pattern shows that copper is dispersed homogeneously on the titania matrix. Figure 2 also shows the absorbance spectra of titanium dioxide and copper modified titania. We can notice a redshift in the absorption peak between titanium dioxide and copper titanium dioxide, and this redshift could be attributed to the charge transfer transition between the semiconductor and the metal. In the UV wavelength region between 200 and 400 nanometers, the relative intensities show in a decreasing order for copper titanium dioxide and titanium dioxide. In the visible wavelength region between 400 and 800 nanometers, we can notice that the absorbance is considerably enhanced for copper titanium dioxide. The test of photocatalytic activity of the prepared material on the removal of pollutants was carried out in a batch photoreactor and under ultraviolet radiation during 60 minutes using different concentrations of catalysts. The following figure shows just results for the optimal concentration. In Dontram blue was used as textile dye pollutant to assess the ability of the prepared catalysts on the treatment of industrial textile dye effluents, and the results are depicted in this figure, wherefrom it can be seen that the photodegradation rate is considerably enhanced using modified titanium dioxide. As a conclusion, and from the results of our work, we can say that deposition of copper enhanced the activity of titania. This significant increase is due to the tendency of the metal to trap electrons from the conduction band of titanium under irradiation, which suppresses the recombination of electron-hole pairs and causes better charge separation. Copper titanium dioxide could be an efficient photocatalyst for industrial textile dye effluent treatment, and it shows an enhancement of the absorbance in the visible region, so this material is capable to work effectively with solar radiation for photocatalytic applications. So that's all I wanted to say in those little 5 minutes. Thank you for your attention, and I hope that I have satisfied you with this presentation. Thank you very much, and I wish the best success for this scientific meeting. Best regards.